All right, guys and girls, you guys were asking me about independent versus dependent on probability. So here's the deal. If it can be replaced or it's new, then it is independent. If it is eaten or taken out or not used again, it is dependent. So it says determine whether the event is dependent or independent. The next two cars you see are red. I believe that would be independent because they're random cars. Determine whether the event is independent or dependent. Is your birthday and it's a windy day. Let's see, birthday and a windy day. Independent? Dependent. Birthday and a windy day. Oh no, check it. Nope. Go back. It's independent because your birthday falls on a different day each year. So we didn't take that away. It's a windy day. That could also occur every time. Okay, got it. All right, keep practicing. Determine whether the event is that a coin toss twice comes up heads both times. That would be independent because you didn't take a coin away. It's your birthday and it's windy. Independent. A bag contains 10 marbles. Calculate the probability of removing 2 green marbles in a row if you do not replace the marble each time. All right, this is a dependent event. So, 10 marbles to begin with. 10. Green. So, we had 2 green. So, 2 green. But then the probability of removing 2 green. So, we're going to multiply that. The next time we'd only have 1 green out of 9. So, the first chance we had was 2 out of 10. But then if we took it away, now there's only 1 chance out of 9 marbles. So 2 in a row. Okay. 2 times 1 is 2. 9 times 10 is 90. So 2 and 90. So that is 1 and 45. Let's see if that's one of our answers. Yeah, 1 out of 45. Okay. So, dependent. All right, 10 marbles. Calculate the probability of removing 3 without replacing. Dependent. And getting all blue. All right, so blue is 4. 4 out of 10. And then the next time will be 3 out of 9. And we have to do it 3 times. So, another one would be 2 out of 8. Because we took 1 away. Now there's only 3. But we also took 1 away from the big pile. Now we multiply these all out. But first I'm going to reduce 2 over 8, 1 over 4, 3 over 9, 1 over 3, 4 over 10, 2 over 5. So 2 over 5 times 1/3 times 1/4 is, 2 and 4 can reduce as well. That would become 1, that would become 2. So 1 over 30. If you want to do the long way and work it all out and then reduce it, this will be the answer that you get. 1 out of 30. Okay. Bag contains 10 colored marbles, 4 blue, green. Calculate green. Green is 2 in a row if you replace the marble each time. Okay, so this one's different because we're replacing it, it's independent. So the first chance we have of getting a green is 2 out of 10, and the second chance of getting a green, well, we put it back in, is still 2 out of 10. So 1 over 5 times 1 over 5. I just reduced this, simplified it. I divided 2 in the top and bottom. 1 over 5 divide 2, divide 2. 1 over 5 equals 1 over 25. 1 over 25. And that was because it was independent. We replaced it. We put it back in. Okay, determine whether the events are dependent or independent. Do I put it back in, which is independent, or is it dependent, meaning I ate one or took one away? Being dealt 4 aces in a hand of poker. That would be independent because, nope, okay. Mutually exclusive. Let's see. Determine whether events being dealt 4 aces in a hand of poker. Don't they give you 5 cards in poker? Okay, missed that one. All right, keep practicing. All right, bag contains 10 marbles. Probability of removing 4 marbles without replacing. Removing them, that's dependent. And getting exactly 3 blue. All right, 10 marbles. Removing 4 marbles without replacing and getting 3 blue. 10 marbles without replacing 4 times. So 10, 9, 8, and now we're left with 7 marbles if we did it 4 times. 3 blue. Blue, blue, blue. Well, we would have had 4, then we would have had 3, then we would have had 2, and then 1. And getting exactly 3. Let's see. I don't know. Let's see if this works. 1 out of 4. 1 out of 3. 2 out of 5. 2 times 1, 2. And 5 times 3 is 15. Times 4 is 60. Times 7, 420. Oh my God, I'm writing on my desk. Oh my gosh. Okay. 2 out of 480 is 1240. No, that is not an answer up there, even if I wrote it on my desk. Okay, so exactly 3. All right, let's try it this way. 10 marbles. So I have initially red, 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 red. Then I had also blue, 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 blue. And then I also had 2 green. All right, that's the first roll. Calculated probability of 4 coming out and then being exactly 3 blue. All right, so the first roll. Okay, so blue is 4 out of 10. And 3 rolls being blue. Moving 4 marbles. And 3 being blue. Okay. 12, 24. 90 times 8. 720. Calculator. 24 over on 720 is 1 out of 30. But we're going to have another. Okay, so 1 out of 30. And then there's going to be another roll that's only going to have 7 in it. And it's not blue. So it could be, let's see, 4, 3, 2. So I could have 1 blue. I could have 4 red. I could have 2 green. 6, 7. 7 out of 7, which is 1. 4 red. 4 blue. I took 3 blues. Maybe I don't count it on the next one. So maybe I just count 6. 6 over 210 is 1, 5. So 1 out of 35. Aha, that's the answer. So you can't count the blue. Okay, using our brains. Determine whether the events are dependent or independent. Being dealt 4 aces in a hand of poker. Dependent, I guess, on what other people get. That's why you don't get 5 cards in a row. They deal them out to different people, so it's not in a row. So that's why. Okay. Probability DE is what? 1%, 0.1% of the population is said to have a new disease. A test is developed to develop the test for the disease. 97% of the people without the disease will receive a negative test. 99.5% of people with the disease will test positive. Let D be the event of the random person has it, and let E the event that the random person gets a positive test result. Okay, so 3%, if 97% without it test negative, that's great, but 3% are testing false positive. Let's see. 95.5% of people will test positive that have it. So 0.5 will test negative, but they have it. God, that's terrible. All right. Let D be the event that the random person has the disease. Okay, they have it. Let E be the event that the random person gets a positive test result. Okay, so positive test result we know is 99.5 and 3%. They test positive. Too bad for them because they really don't have it. And then let D be the random person that has the disease. So, okay, they have it. Let E be the event that a random person gets a positive test result. Find the probability of either having it or testing positive. So I guess they're doing the 99.5 and the 3. So that would be, all right, so which 0.1% of the population has it? So maybe I add those together. Add them together. Let's see. 112.5 times 0.1%, 0.001, 99.5. Let me try it. Let's try it. 112.5 times 0.001 is 1,125. 1,125. I just multiplied it. Okay. And then 1,125. They don't tell us how big the population is. She wanted you guys to do day 1 fraction slide.
I can't find either of those.
And the review. Okay, we'll look at it in just a second. Okay, guys, I'm just gonna have to guess on this one, because I gotta go. But again, if it's a really tough one, they'll adjust it, make it easier. Let's see what 995. 5 divided by 30965. 0.03, so 3%. That must have been the false positives because we had 3% that were the false positives. Huh. So that's what we were looking for? Which one was the false positives? Maybe so. All right, it's getting late. Gotta go. Love y'all. See you tomorrow. Bye.